Today we're going to talk about limiting reactant. Now, this is something that we've been alluding to since kind of the beginning of stoichiometry, but this is where we're going to officially do the math for it. If you think about making peanut butter and jelly, and you've got 4 slices of bread and a big old jar of peanut butter and half a jar of jelly, how many sandwiches are you going to make? Well, we know we have 4 slices of bread, so the most we're ever going to make is 2 sandwiches. It doesn't really matter how much peanut butter and jelly we have. The limiting reactant in this case is the bread, and we can't make any more than 2 sandwiches from 4 slices of bread. So in this case, the excess reactants are the peanut butter and the jelly. The word excess just means that we have extra of them. They're in excess. So the limiting reactant is the reactant that runs out first. We care about this because it's going to determine how much product will be made. The excess reactant is added to ensure the other reactant is completely used up. Usually the excess reactant is cheaper and easier to recycle. So for example, with the baking soda and vinegar in our baggie lab, the excess reactant was the vinegar because I had a huge jar of vinegar for you. So how do you find the limiting reactant? These are the steps. I'll go through a bunch of examples. But the first thing you want to do is assume all of the first reactant gets used up and determine how much of one of the products will be made. If there are more than one product, then you just need to pick whatever one you want. Do the same for the second reactant. And if there's a third reactant, you need to do the same for the third reactant as well. The reactant that makes less product is the limiting reactant. By the way, the word reactant is going to be the same as the word reagent. So if we see limiting reagent, that means the same as reactant. So here's some examples. Really simple chemical formula here. If you have 18 moles of sulfur dioxide and 7 moles of oxygen, what is the limiting reactant? So in this case, and every case with limiting reactant problems, we need to do 2 separate stoichiometry problems. First, I need to find out how many moles of the product I'm going to make if I start with 18 moles of sulfur dioxide. And then I need to figure out how many moles of the product am I going to make if I start out with 7 moles of oxygen. So if I have 18 moles of this, I can make 18 moles of this. If I start out with 7 of this, I can only make 14 moles of this. In other words, this is never going to be made. This is what I'm going to make, just like I can't make 10 peanut butter and jelly sandwiches if I only have 4 pieces of bread. This is how much I'm going to make, and therefore the oxygen, or the O2, is the limiting reactant. O2 is the limiting reactant because it makes less. Here's another example using the exact same formula, but this case we have grams instead of moles, so we have an extra step to turn it to moles. So if you start with 38 grams and 20 grams of O2, which is the limiting reactant? So we're going to go through, we're going to change grams into moles, then moles into moles by using the balanced chemical formula, and we get an answer of 0.59 moles of SO3. If I wanted to go to grams, I could, but it would be a little bit of a waste of my time because in this case, it's just asking for the limiting reactant. So I'm going to go through and do the same thing with the oxygen, grams into moles, using the balanced chemical formula, moles into moles, and I'm going to find out that with 20 grams of oxygen, I could make 1.25 moles of SO3. I am never going to make that because the SO2 is going to make less and therefore is the limiting reactant. Here's another example. I encourage you to pause the video if you would like to try some of these on your own, but how much NH3 can be made in grams from 118 grams of N2 and 35 grams of H2? So now I'm not asking which one is the limiting reactant, but I'm asking how much am I actually going to make? So it's a little bit of a different question, but I still am going to start with 2 stoichiometry problems. I'm going to start with 118 grams of N2, going to convert that to moles, and then going to convert it back into grams. So I've got 144 grams of NH3 that I could make. Doing the same thing again with 35 grams of H2, converting it to moles, moles to moles, and then back into grams. So with the 35 grams of H2, I would make 200 grams. I'm never going to make that because I don't have enough of the nitrogen, the N2. So how much am I going to make? I'm going to make 144 grams because the N2 makes less. So it's the limiting reactant. It's going to make 144 grams. Here is another example. If you have 16 grams of C2H2 and 16 grams of water, just because they're the same amount doesn't mean you can automatically say that one is the limiting reactant or one is not. You still have to run through the stoichiometry problem. You start with a stoich problem for each. And again, this is probably getting pretty repetitive, which is good. Balanced chemical formula, moles to moles, and then back into grams. We find out that with 16 grams of C2H2, and if we had all the O2 in the world, we would make 54.1 grams. But we don't. We only have 16 grams of O2. So we've got to calculate and see if that's going to limit us. Convert that to moles. Moles to moles, and back into grams. So in this case, I can only make 17.6 grams of CO2. So which is the limiting reactant? It's the O2. The O2 is the limiting reactant because it makes less. Now you'll notice here I went all the way to grams and I didn't really need to. I could have stopped at moles there. But maybe I just got excited about converting stoichiometry because maybe the next question is, how much can you make? And then I would have my answer ready to go. This is another kind of question. It says, how many grams of the excess reactant are present at the end? So if you go back and you think about the one that we just did, all right, and again, we go through and we imagine that this 5.2 grams of C2H2 is what you actually need to use to react with 16 grams of O2. All right, so 16 grams of O2 is what I'm starting with, and 5.2 grams of C2H2 is how much I actually need to react with that. So how much is excess is present at the end? Well, I don't know if you remember, but we started with 16 grams, but we only needed 5.2 grams. So that means that 10.8 grams are in excess or remain at the end. So this is pretty much as complicated as it gets. What is the limiting reagent or reactant if 8.65 grams of aluminum reacts with 20 grams of CuSO4? And then I ask myself, well, how much of the excess reactant will be left over at the end? So first, I start with my limiting reactant problem. Two stoich problems, grams into moles, moles into grams. You'll notice here there are two products. Which product do I use? Really, whatever one I want. In this case, I didn't feel like finding the molar mass of Al2SO43, so I just used copper. And I found out there that I would produce 30.6 grams of copper if I had 8.65 grams of aluminum and excess CuSO4. Well, if I had 20 grams of CuSO4 and I ran through the stoichiometry again, I would produce only 7.96 grams of copper. So that means that the CuSO4 is the limiting reagent because it makes less. I'm never going to make 30.6 grams of copper. Now, the next part of the question was, how much of the excess is left over? So we start with the 20 grams of CuSO4, okay, and we need to find out how many moles or how many grams of aluminum do I need to react with that. I need 2.25 grams of aluminum. In the problem, that is how much I need to react with 20 grams of CuSO4. I started with 8.65. I used 2.25 grams of aluminum, and that means that 6.4 grams remain or are present at the end. Last example, pause it and try it on your own if you want. How many grams of silver will be formed when 12 grams of copper react with 22 grams of silver nitrate? So I've got 12 grams of copper. Going to find out how much silver I'm going to make. I am going to make 40.7 grams of silver. Now let me start with 22 grams of silver nitrate. Grams to grams, moles to moles, back into grams. I can only make 14 grams of copper. So for the last time, the less amount, it is less, that is how much you are going to make, which makes AgNO3 the limiting reagent.